Well, it's 1 o'clock, and we can go ahead and get started because there might be a chance we run a little bit out of time here. This is a brand new presentation. First off, thank you everybody for coming today. And my name is Steve. I've met a lot of you today, and some of you haven't. So if you'd like to say hello to me after the presentation, I do have a booth right by the main entrance. You just have to hang a right, and you can see the CRTs. I've got a couple other CRTs and things there. And anyway, I just wanted to let you know this class is, again, brand new. It's about how a CRT works. And so, bear with me. We might work through some things. And this is a monitor here that is from 1993. And it is very complex. So we're going to walk kind of through this thing, talk about how a CRT actually works, what's actually happening. And as you can tell, this technology that is right here looks so much different than the flat screens of today. There's so much more going on here, and the reason really has to do with the video format itself. So I'm glad, again, to do this. I want to say a quick thank you to everybody who has helped put this show together and let me come and organize this, like Dave and his team here at the convention. And thanks again for everybody to be here. And just real quick, a little bit about Retro Tech and my business. We do primarily restore and repair CRT televisions and monitors. And the mission statement for my business is resurrecting vintage technologies for the modern world. And that's pretty much the goal of when I started Retro Tech, and now it's been about 6 years. Last 2 years I've been doing this full time. And the really crazy thing is there's really nobody else trying to do this anymore. A lot of the people that I talk to, who I confide in and try to get any kind of knowledge from on these machines are, most of them are in their 90s. And they are infinitely knowledgeable on these pieces of machine because they spent their whole lives working on them. But unfortunately, when they go, a lot of the knowledge that was with them will be passed and will be gone forever. And so I'm trying to help by preserving that and preserving this machine for the next generation, and to make sure that people will be able to learn from this and use this, because it still does have a good amount of use in our modern world today. So that's just a little bit about that. Now, what is a CRT? Well, there's going to be some acronyms and things that we're going to go through today. So in case you've never heard of that, CRT stands for cathode ray tube. And that's pretty much referring to this device right here, which is, the major part in this whole tube television or monitor setup. That is the tube itself. This is an 8-inch tube, so it came out of an 8-inch monitor, but it's just a scaled down version of the one in our demo unit today. And you can just see how big and different. It looks like a light bulb, but what it really is, it's a vacuum sealed glass tube, and then it's got an emissions part up here, and also a cathode and an anode cap, and then right here. So basically the way this gets an image onto the screen is the information is sent in the back here that you're going to display through your pictures, sent through a board like this. In here, it goes through this device inside the glass, which is called an electron gun, and then your image is blasted in beams on the front of the screen. So it's a completely different technology than our normal technology, and that's why there's a lot of weird, almost tricks and magic going on when it comes to a CRT, because if we could slow it down, we would see that all that's happening is these lines are being individually drawn on this tube face of the mask, and all it does is it does it at such a high speed, our eyes can't see it. So we don't see the flashing or the blinking. We just see it as a smooth, constant image. Now, that's kind of a little bit on the tube itself, and we're going to use some other tricks here to do things. So that's a pretty, curved tube there. That's a Sony style tube, which they only curved on one side. If you go out to the showroom floor, you'll see many that are curved on all sides and flat sides. And that is just to help, early on these tubes had to be more and more curved because when you're shooting an image through there, how do you get it to spread out evenly and show up evenly on that screen? And the way that was done was through this device here, which is called a deflection yoke. And so what this does is this directs your beams, and it tells them where to land on the front of your screen. And so that's the way that what happens here is the image is projected onto the screen, and the deflection yoke tells it where to land on your screen, and then you see it on your screen. And that uses magnets and magnetism. That's how that's drawn out. Those electrons are shot onto the screen, and then magnetism is used to pull them out and give you an image. And so that's a little bit on just how that's getting to the screen. And we're going to fire up this monitor here in a second. But just before we even do that, I would like to make a mention on safety, because these machines do have the potential to really hurt somebody if you do not know what you're doing on them. And that's probably one of the biggest keys, that if you can remember anything, just remember that you probably shouldn't just go and open your CRT at home and just like try to do what I'm doing today, unless you're really ready and really study up on what is really dangerous. Because this point right here, which goes into our tube in this hole right here. Now, this is not a hole that goes down into the tube. It's literally just a little diameter, like almost coin metal piece where electricity can go. But that can get up to 31,000 volts that goes into it while it's turned on. So you would never, for example, want to have your hand really on that area right there when it's running. Now, that is like the most important thing, is that anode cap. Now, the good thing is when it's turned off like this, it's not as it's pretty harmless, except again for that anode cap area, which I know you see me touching it. But again, these monitors are not, they're not going to shock me, but if you don't know, you could get shocked. So there's always that. I need to make sure everybody knows that. But we're going to go and just talk a little bit more about some of these parts. So where that really high voltage comes from is right here, this device here, and this is called your flyback transformer. So that sends in that high voltage into the back, and at the same time your image and your data is sent in through this neck board, and all the image is processed from the back end here. It's your signal goes in and it comes out the tube, but the information is sent from the neck board. And then there's other parts to this individual CRT that make it function. We've got our main board at the bottom, and then we've got, again, at the back here, at the back here, our input board. And then you can see where we've got RGB into this particular monitor. Now, a standard CRT in North America will not support RGB. It'll support normally composite video or RF video, or even if you have a better one, it might have S video and then component inputs. But RGB is just straight red, green, and blue, and then sync. So you're not doing any processing on your colors. You're just sending them straight into the monitor. Again, that was not a standard that people were using in America, so we never really got a at-home use for it. But these monitors were commercially produced, so they had the inputs for that because they had commercial products that would use RGB. And then the reason that RGB is just so coveted now is because it's the best way to get retro games, clearest picture quality as you can, is through straight RGB into something that can read RGB properly. And thankfully, with this device, you don't need anything else. You don't need any other devices to try to, de-scramble that or convert it into something that can be used on a modern TV. This one just takes it, accepts it, and spits out the image. So that's a little bit about that. Now, the image quality we're going for here, again, is higher, but also on the flip side of that, the reason, again, these are so desirable is the video signal itself from the older devices is actually a lower resolution than most modern devices will even be able to handle or properly interpret. So what I mean by that is this is running in the old school, either 480i, interlaced, that's when I say I, that's another acronym, interlaced video, or if we're going down even lower than that, in video games we're going to 240p, which is just 240 lines on the screen of progressive display. And so that is the reason that when you look at this screen, and if you guys want to look at this later, you're welcome to at the end of this, but if you come up and look at real close, you'll actually see the blacked out lines, because this screen can display, again, 480 lines, but it's only showing 240 lines are lit up, so the other 240 are left out blank, and it gives this black line in between each line, and so you don't have any flicker on the image, you don't have any, or you get an extra sharp look, and it's called scan lines. So if you hear that term, that's what scan lines are. And then the other format would be 480i, and the way this interprets that is it's going to show 240p twice almost. So it swaps it shows it interlaced, so it's not always progressive like this. It's flashing back and forth the 240 lines, and then that's why it might flicker on the screen when you're watching, for example, like standard definition television or an older movie or something. So this thing here we're going to do is, I'm going to move on and we're going to do some demonstrations now on this screen, and we're going to go through some of the most amazing software for CRTs that you can find, and that is this 240p test suite from Artemio. And this is an open source free software that I've got a nice cartridge for it for my Super Nintendo. But this software is designed to be used in old devices like a Super Nintendo, and it's going to give us some incredible test patterns to be able to verify that our CRT is functioning, and also what happens. You could use this on other displays, but it's especially effective for CRT for checking the condition of the CRT, as well as making adjustments to your CRT and seeing if you're doing things the right way and how it looks afterwards. So it's really set up nicely. We've got test patterns in here. And if I just click on test patterns, we've got a bunch of different test patterns to choose from. But one of the ones that I really want to focus on most of all is this monoscope pattern. Okay? And this monoscope pattern has, it just looks like, obviously like squares, right? And different shapes. But we can use this kind of a pattern to judge things on our screen. And we can see, well, okay, so up here I might have a little bit of a color separation at my edge, because I can see that up here at this corner. Or there'll be other anomalies we can show in the screen. There's even some better color separation up here. So we can do things to try to improve that as we work. But also, if we have other things happening, this monitor, you have to adjust it internally. So it's a lot of fun to show you guys because, again, this is super old. Some new monitors and newer televisions, most of them will have a remote, and you can do all this without getting inside. But that wouldn't be as much fun for me to just sit around and hold a remote control and show you guys me flipping through a service menu. Okay, that's boring. So we can manipulate this image on the screen with these amazing control board back here that you guys can't see from where you're sitting, unfortunately, but it's got little things I could stick this screwdriver in and turn, and you'll see image adjustment on the screen. So let's just try some of that stuff real quickly here, and we'll see what it does on the screen, and then we'll see if we can make it look even better. We can judge some different things on here. So the first thing I'm going to do is I'm going to spin one of these potentiometers on here, and I'm just going to make sure that we're doing something on the screen. So you see there, this is our horizontal size control, right? And it's just crazy that you could just sit back here and turn this, and manipulate that image. But if you have an issue, if you have an issue on this TV where you see that the horizontal size isn't big enough, well, then you can just expand that here, and you try to expand it out to the edge. You're like, okay, that looks pretty good. That's a little bit better. And then you look down here, and there's a bunch of other ones, and we'll find the next one, which will be our center. And let's hope I can find the right one. It's hard to see. Some of these they're not labeled perfectly, but see, that's the wrong one. And just start seeing if we can't find it. Well, that's a different one. See? So the way that this is all working is, again, these potentiometers are controlling the signal that's being sent to this deflection yoke and the amount of energy being sent to this, the magnetism. I'm manipulating that magnetism by using this screwdriver and these potentiometers to adjust the screen. And you know, the reason you would want to even do this in the first place is just to give you a better looking image on your screen when you're using it. And that's why you're using these tools. So just to give you a little bit of a run through on this pattern, because we're going to do some more adjustment on it. But the way this pattern is designed is the reason we have these squares and all this stuff kind of sectioned out is because, again, we could have issues on any portion of this screen. So we want to try to make these look uniform. One of the biggest key components on here is these are supposed to be squares. So if they're a little bit oblong or wrong shape, then we can use these adjustments to try to make them be squares. The same thing with this bigger square. So if we see just the red square, I can actually use this software and get rid of all the other squares and just use the red squares. The red squares are designed to help you with your aspect ratio. So naturally, as I go through there and I adjust the size on the outside and the size vertically, well, if I did that and I didn't set that to a correct aspect ratio, then I could have like a oblong-shaped Mario, right, when I'm playing, because I have not got it right on the aspect ratio. So this tool is set up so that you can check your aspect ratio. And to do that, you just measure this side and then this side. And same thing with the larger square. And if those two measurements match, then you have perfect aspect ratio. So that's a really key thing for this tool kit and this software is we can use that to make sure that our aspect ratio is perfect. And that will help, again, if you're playing a game and you don't want something to look a little bit misshapen. The interesting thing is when you do that and you do set it for the aspect ratio that's correct, you have to end up overscanning your image a little bit to get it to fit the screen as well as be in good aspect ratio. Now, I do apologize because they do not put these in any particular order, and it's very difficult to see every little adjustment on here, but I think I found what we're looking for. Maybe? Well, vertical up and down. And then, so that's, rather than me getting too much into those parts, that's kind of the adjustments for specifically geometry, is you would go in and you would play with these, you would check with this pattern, and again, just try to get that all lined up, and then that will get you good aspect ratio. Now, some other things that we can do is we can talk about some other issues that you will probably find in a CRT, and we will try to go ahead and almost mimic that here again with this thing. So again, I was talking about this deflection yoke, and this thing is very finicky. So if at any time it's leaning a tiny bit, you'll see a big lean on the screen. Or if it tilts one direction, it'll completely mess up the image quality on the sides of the screen. And so we'll just, to show you basically how that looks, I'm just going to open this here, and we're going to move this yoke around a little bit. And you can see how the image looks, right? It changed a lot? Did it change a lot? I mean, like, it's just crazy that it's all magnetism. And if that is not, again, set correctly, that easily over time, that can move, right? Because, I mean, these machines are from 93. That's almost 30 years. So very often that will move, and you'll have a crooked screen, okay? But something else that can happen is let's go to a different type of test pattern. And that should be our colors, white, red, and blue, and green. Okay. So this is a white screen. Okay. If this starts to go back a little bit, look at our colors on the side. If our yoke comes back just a tiny bit, it completely goofs up the colors. And you might look at this and think this like tube is shot or something. But it's really, all it is the fact that the yoke is not pushed back up into place. And same thing. You know, you'll get different, you might have a color here, and you could see where you'll have a big purple washout or something. So that just shows you how much, how finicky this thing can be, right? Okay? The other thing that may happen is you may have components that go bad actually on the board. And that's going to be normally electrolytic capacitors. And what that will do is that will make it so the adjustments that I was trying to make wouldn't actually do anything on the screen. Or they would make the screen not look quite right. It might always look oblong. It might always have a hook at the top. Now this one doesn't have those issues, but if you want to, I can go around and show you some CRTs on the floor with some issues, and I can show you we could define what each one of those is. But, so you may have an instance where you can't even get something in perfect shape because the capacitors may need to be replaced. Because capacitors were only meant to last like 15 years. And again, we're already past that on most of these machines. So the bigger, lastly on these adjustments, there's other things too that will affect our image quality. Now the flyback sends, and we talked about that, sends that high current, that 31,000 volts in. If it also has to be tuned, and I'll show you how that looks. Maybe I could just leave it on this screen and you'll probably be able to tell pretty good. And what we have to tune on that is called our focus. So this sends in a beam, and then it's actually got focused. So if I turn, you see how blurry can you guys see how blurry it just got? And like it doesn't look sharp at all. Well, that could be a simple thing of turning the potentiometer on the back of the flyback so that beam is focused. It's literally called focus on the back of the TV. And then another one that's fun is our convergence. And I'm not going to get into the details of just like corner convergence because that can be very finicky. And it's more of a advanced level of repair there if you ever have to mess with convergence rings in the corners. But there is an overall master convergence control on a CRT. So not everyone, but the high-end ones do have it. And if I adjust that, see that the beams on an electron gun are shot in 3 major primary colors, red, green, and blue. And again, that has to be lined up perfectly or you'll see colors separate. So that's what I see. So you see separation here of blue, green, and red. So that just means those beams have been spread out too far, and the attempt is for the machine to send those in and make it clear, but if we don't have that adjusted correctly, we get it separated on our screen. So those are just some of the more master controls that are on most CRTs. And one of the more fun things here, I wanted to check us out on time, we're doing good, is let's go back to a white, red, green, and blue screen. So this is a good check for a couple of things. First off, sometimes, again, a CRT will have three primary colors that it's pushing on a color tube. If the colors don't look right, there's a chance that one of the colors is out in the tube. And what happens is over time, this is an unrepairable problem, unfortunately. What happens is the gun that's inside this tube shorts out one of the colors. It shoots three colors, red, green, and blue. Well, occasionally one of those colors, two of those colors can short out. And then you pull up these color screens on this test pattern, and you can cycle through them, and it'll show you each individual color. So that we have red, green, and blue, so we can verify that all three of those colors are still working. And then white is just all those colors at once, and it's maxed out, and that's pushing all those colors. And black is everything off, no image. So that's a way to test the tube to make sure that you're getting colors, but also we have, since this is all magnetic and everything is affected by magnetism on a CRT, we can get magnetic interference onto our screen. And that can be because we set a unshielded speaker too close to it, and then this color will change. Or it could be from a magnet in your pocket, or you just pushing a magnet on the screen, and you can get a magnetic issue. So I'm going to push this back up a little bit, try to get rid of that purple down at the bottom. And we're going to do a demonstration here of magnetism and how it affects the screen, what will happen to the screen, and then we'll correct it. But just so you know, this is something, again, this is a pretty specialty tool here, and it can be dangerous and a fire hazard if you don't know how to use it. That's really a rare situation where something like that would happen. But this thing right here is called a degaussing wand, and it is a commercial piece of equipment that generates an enormous amount of energy. It's going to generate a magnetic field, and then it will... you can't keep running it too long because it gets extremely hot and it'll melt. So you don't want to use it for more than 2 minutes. And that's really the big warning. But what this does is if we get some magnetic interference on this tube, it's very hard to get that off and clear it up. Now, a lot of these will have a manual degausser. And that's what you hear at the beginning of when you turn the TV on, and sometimes you hear that bong, gong sound. That is the internal degausser going off, and it's trying to balance that magnetism, but it is not usually powerful enough to get rid of outside magnetism. So for the demonstration, we're going to introduce some funky magnetism to this. So if I just do this, we are going to whack out the colors, right? So there it is, right? I've gotten this one of the fun things I like to do on my YouTube channel is I love to go and buy CRTs that are listed as being in great condition. And then, you get them home, you fire it up, you unbox the thing, and then you turn it on and you're like, oh, this is perfect condition, right? It looks great. So, because if I know that's a red screen, but if I go back here and I start up my normal software, we saw how it looked at the beginning. Well, now I'm like, what the heck? That doesn't look right. And no amount of, we will try. Let's see if we power cycle this. Maybe we can hear that gong, because this one doesn't have, it does have the ability for me to do it. I'm sorry, I'm a dummy. Okay, let's let it go, turn back on, and see, there is a degauss button for this one. See, it'll do that. Oh, well, see, that did too good of a job. See, so that one cleared it up. So that wasn't any fun. That's not, there we go. So the internal degausser, it can clear it up sometimes, but if that doesn't clear it up and you hit it and it still looks like this, that's where this magic wand comes into handy. And I'm going to show you how we use this to clear this screen up. And the best thing to do is for me to go back to that color page so you can kind of see it a little bit better. Okay. I like using the red. It seems to come out really nicely. So the proper way, this has a method, you got to kind of hold it and slowly go in and make a circular motion, get close to the screen, And then that's my favorite part, right? That looks pretty darn cool. And then you slowly back away, make your ring bigger, and almost pull your power supply off, but we're good. And that's it. That's like demagnetized, the electrons have been balanced, and it's literally just that easy with the right tools. Because otherwise, how would you ever figure that out? I mean, it's like, it's an issue that's correctable, and just a lot of these tricks and things that I've been talking about have just been forgotten, and we've got to do I'm doing my part, try to preserve this information and help out. Now, well, I've gone for about 30 minutes here, and I'd want to give an opportunity to anybody if they have any kind of questions about anything I've said. If you'd like me to explain anything a little bit further, I'd be glad to do anything I can or show you anything on here.
Yes, sir. Yes, I had a question about, so I've heard people talk about PVMs. So is that what that is, and why is it so valuable? Because they use them a lot for like retro fighting games and stuff like that. Because it has RGB.
Yeah, so there's a lot of reasons this is so special. This is a PVM, and I didn't even get into those acronyms for this one, but that stands for Professional Video Monitor. And again, these were the ones that would have been made commercially between like 1980 up until about 2000, and I think the most recent was like 2009 almost. They were still making some sort of professional video monitor in a CRT format. Now the reason they are so desirable is quite a bit reasons. First off, you saw the controllability I had on the screen. You don't normally get that kind of controllability over your deflection and your adjustments with a standard television or non-PVM. PVMs are meant to have better picture quality. So one part of that is your adjustability. Another thing is the tubes in them are higher resolution. So this tube has a higher resolution video image than it would on a standard. This one has, back then they used to call it line count, the line count on a tube. This has 600 lines of resolution. A standard TV in your home or from the time period would probably only have about 200 to 300 lines. And so this is quite a bit more sharp, and then of course you got the ability to add or to get RGB and all these other inputs that weren't available before. Another thing about it that's very important is these, there's a lot of great things about CRTs, but there's not latency in these. So if you are fighting games or anything where you're relying on timing of the image, there's no latency, so relatively none. So you're going to be able to, see a reaction time is really quickly on this. So that's another big reason. I'm sure there's a bunch more, but those are some of the more front-end reasons. Now, one more thing about the tube. There's two types of tubes. There's the Sony tubes and everybody else's tubes. Okay. And that's not like a lie. That's like the Trinitron tubes were a different technology that Sony made. They patented the technology, and then until the patent ran out, you weren't making a Trinitron unless you made a deal with Sony. And the thing that was different about Sony's is when they came out, they only had glass curved on one edge, where you can see that. It's curved on that edge, but on this edge it's like flat. So there's only one curved side. Whereas the other technology at the time was called shadow mask. It was curved on all sides, and the gun was the different part. The gun internally. That internal gun on a shadow mask or everybody else's tubes was separated into 3 individual colors. So you had a red gun, a blue gun, and a green gun within this. So it was a 3-gun setup. Well, Sony came out, and the way they wanted to change everything was to have a single gun that could shoot all the colors. And then they were able to perfect that. It almost broke the company, seriously, and they almost gave up, but they were able to finally master the Trinitron technology of the electron gun tube setup. And the reason that they wanted to get the production cost and time down, but also the 3-beam system on the other TVs is very much harder to converge and adjust. It was much wilder on the picture quality at the time, and you would have to have an engineer in a factory, after you produced a set, they would spend tons of time adjusting that set. And so Sony figured that if they could get the beams closer and just coming from one gun, that they would be able to eliminate a lot of that adjustment or make it a little bit easier on their techs, which it did work. And like they pretty much changed the industry as far as televisions was concerned. Their qualities were higher. Now there were other good companies that made the other style of CRTs, but Sony really, they wanted to be different, and it worked for them then, big time.
So I had two CRTs, one big and one small, and like I've always been kind of gun shy about opening them, right? But like I noticed that especially the big one is caked in dust on the inside, right? Mm-hmm. So like they've told me that, like I've seen on the internet that if you spray computer like dust in there, that it will like kind of mess up with the electricity in there because it's electronically charged and stuff. So I was just wondering like what would be the best way to prove that, would it be safe to take that off, like the backing, and just kind of go up in there and clean it,
Yes. That's a great question. The vast majority, especially of home TVs, if you go, nowadays you can go still and find good CRTs if you want to get one from like Facebook Marketplace where somebody's giving them away locally. And you don't have to invest in a PVM like this. You could start with something that does almost everything this does, and you could get like 85% of the experience of a CRT and get all the great things about it. It's just this is like, again, the hot rod of a CRT is these higher end monitors. But they're always, especially the home ones, always seem to be dirtier because they just sat there, got skin, dust, maybe smoke, maybe everything, settles inside of it for 15 years, and it's never been opened and cleaned. These professional monitors are designed to be serviced, so they were serviced and they were cleaned. So the best way to clean them is not to use the computer thing. Believe it or not, these old paintbrushes work fine to brush off dust. You just want to make sure you don't get anything that's really conductive. This horsehair is not conductive. But what you can get ESD brushes. You make sure the TV's obviously turned off, right? You don't have to mess with that anode cap. You could dust around it with this. Just dust it, knock it off. And then instead of using compressed air cans, you can, they're like $50, but there's just a little hand blower that you get off Amazon, rechargeable. And that's what I use because there's it's real handy. You can get in places. It's ESD, so it's not going to carry any electricity. You're not going to short anything out. And again, it's rechargeable. And if you go with dust cans, you're going to spend $50 in dust cans probably on a TV. And so that's really the best two ways, is a brush and that. If you have access to like an air compressor, that would be fine too. I would just say watch air compressors because they can throw moisture, like water, can get built up in those. So just make sure that if you do use a professional air compressor, they're highly effective, but you might want to give the CRT a little bit of time if you suspect there's any kind of water in your line. Great question. Anybody else?
On the you were mentioning the electrolytic caps going bad. Can they be like replaced with modern day caps?
Yes. So the majority of my work is going in, and now people would bring me their CRTs, and there are tools and testing equipment where you can go through and actually check those capacitors without removing them, and they'll tell you whether they're still good or whether they're bad. So obviously, if anything comes back bad, we go in and we remove that capacitor and we replace it with something modern that meets the specifications of the old capacitor, which is easily met, and thankfully they are reproduced. But we get a benefit because actually the newer capacitors have higher life expectancy, generally better performance, better heat disbursement. So you're going to get, thankfully we can do that and replace with newer stuff and get a benefit there.
It's in a similar fashion, if you have a part that's bad, is there any part of it that's just like this?
This is done? Yeah. So, right, I had mentioned this is a primary component, the tube itself. So, like, things obviously happen with this tube where they eventually go bad. After hundreds of thousands of hours, they will go bad. You get things where the image starts to burn And you can look at this, it's called image burn, where the tube will get things stuck in the image that can never be gone away. It's like, it's a screen burn, like for people nowadays are worried about OLED screen burn, but these were much more susceptible to that. So you'll get tubes where you can see, if it's turned off, this one has screen burn. So it came from production house, and it had time stamped numbers in the bottom because that's all it was on it all day. So the tube can go bad. Flybacks. Now, sometimes you can find replacement parts for those things, especially on like arcade machines. But for some stuff, these kind of things, like the flyback parts and assemblies, those are not usually reproduced, at least not for the higher end ones. So that's an item that if it goes bad and you can't find like a salvaged part from a bad unit, you're not going to be able to fix it. And then, of course, this yoke. So this yoke, you see all these are, the way it does the magnetism is through those copper windings. And those windings they're covered in an enamel. So it looks like, violently you'd get electrocuted if you touched this or something while it was turned on. But it's actually coated. And what happens is you could get a short where one of those coating burns through, wire burns through, and you may be able to patch that. But if you can't, and there's too much damage to the yoke, then that's a primary part. There are some chips in here that are hard to find. So if you have an issue with certain chips failing, the same thing. That could, you're just basically trying to find old parts that are most likely salvaged from something. But if those parts that we just went through are still in decent shape, all the rest of the parts in this CRT can be replaced with modern parts that are created every day and used in modern things. Things like resistors, diodes, these are all circuit board components mostly.
So like, I know Sony especially, they're like in like default settings, but like, not that they're messed up, but like they have a lot of it's called the red push, right? Mm-hmm. I turned that off, but like the default settings for like the sharpness and the contrast and stuff like that, like I turned it down because I didn't want my tube to burn out. That's why they say if you keep it up like on the default brightness, it'll be like burning out. I was just wondering, like, what was your opinion on that?
Yeah. Okay. So the only thing that really will affect your tube is going to be, contrast and then brightness. If you start to pump that really, really high, it can use your tube out a little bit faster. Sharpness won't matter. Okay, and any of those other kind of filtration and things like that, that's not really going to do it. It's just that the brightness and the contrast, which are both pushing the image intensity, that can burn the tube out a little bit more. And then, like, with that, what can happen is the interesting thing is when Sony, like their highest end monitors were called BVMs, so you had PVM Professional. Well, there was broadcast video monitors, which were the ones that were in the Hollywood studios, the ones that were in like the editing, Paramount, whatever, pictures. These were the things used by professional companies, and they would cost upwards of $40,000 for one of those. And those had such insane hardware that the hardware was like twice as powerful as the tubes itself. So there were literally bulletins that I've found from Sony warning of sending too much contrast and too much brightness. If you turn the wheels up, it could literally implode a tube because it's so powerful. It's more powerful than the tube could handle. And they had that happen because, again, you go into your production thing, a wall of videos, you're just a worker, you go up, turn the brightness, boom, and Sony was glad to come in and charge you for a new tube installation. I think they charge like $8,000 for that.
But like, would it like messing with those like levels? Would that improve the image like in any like beneficial way?
Sure. So we could talk about like how do you. There's this toolkit that I've been showing you is loaded. I mean, I've only gone through a couple of tools with you, but it's just filled with these great tools. And one of them is this. And this is just, probably some of you have seen this before, like a color bar, right? Well, it's very difficult to see from where you're sitting, but this is three different black cubes that are like this over here on the side. And so within this middle cube, there's 3 individual lines. Now I can see them because I'm right here, but you need to set your brightness and contrast so you can barely visibly see that. And if I go up, I should be able to go up, and maybe you can see them from back there, but I don't know. This one might not be able to go that high. But see, can I see those? Does anybody see those a little bit? Those individual lines? So the idea is to turn that down till you can barely see that, almost like in a modern set when you start something and it says show, when do you barely see it, press A or something on a modern game, on a modern display. But yeah, if you guys have any interest in, if you use like emulators, or if you use a flash cart, or if you have any access to getting this, the software is free, and like you can go there and you can download it. I just happened to bought this cartridge for my Super Nintendo. But again, it goes for every console. There's even some arcade ports for it, and the reason is we want to be able to check these tubes, and really any display, because we can use this same thing to see we can use this same software to see how bad like this old stuff, these old signals look on a modern TV. Because if we hook this up, it would look completely different if this was hooked up to one of these modern screens. It would show all kinds of artifacts and things that we aren't seeing on these old screens that are meant for this. Any other question?
Yeah, if you can't fix it, how do you environmentally friendly?
Sure. Great. Yeah, that's an awesome question. One of my favorite things about my whole business is that I don't want these things to end up in landfills and e-waste and things, because this is not an environmentally safe item. This is lead-lined glass full of these tiny phosphors and all this stuff that is very harmful to the environment or to humans and any animal, really. And so you can't just recycle this as normal glass. It can't be turned into, artisan beer bottles or something. It's got to be, it's very limited what they can do with it. If there's a few places in the world that can accurately melt this down at high degrees, and they separate the lead from the glass, and then they can recycle it. But there's literally 5 places in the world that probably do that. And the problem is, for years, these were just sent to recycling places, and they said, we'll recycle it, but instead they pretty much put them in sea containers and shipped them over to different areas, and they just wound up on the earth, just sitting in piles. So what you can do is, if you want to do this, you can send these things. Usually the local municipalities will still take them. I don't know what they do with them, but I'm sure they probably don't get rid of them properly. There are companies that you can send, they'll send you a box. You have to pay for the shipping back to them, but you can ship them the tube, and they'll get rid of it for you. But the EPA says the best thing to do with these tubes is to try to preserve them and keep them running, because there's no cost-effective, or even infrastructure right now to properly dispose of them. Yeah. So yeah, if you're going out getting, you're really a green gamer, okay? Team Green Gamers, right? Because if you this is a really green idea to get these things out of the landfill. Any other questions?
Do you only salvage parts, or do you ever find new old stock parts for the?
Yeah, we can, if we're lucky. There's this is a new old stock part right here, actually, which is just the anode cap. It's to a specific one, and it came in a Sony box. This is the original box for it. It's got a part number right there. Sometimes, so these things can get shipped a lot. I mean, it stinks, but they do get shipped. This power button down here is just a push button. That's plastic and breaks all the time. I actually was able to, I had a customer send one just like this. Their power button broke, and somehow I found a new old stock on an actual parts website. I ordered it. It took like 2 months to get here, but they sent me it. It was brand new, old stock part. It was like $20. So you can still be lucky and find them out there, but it's also a gamble. Are you getting, something that was salvaged too, or a knockoff part? It's not. It's a lot of times that's why I end up with like a storeroom filled with broken monitors. It's almost like a junkyard. You want to hold on to something because you never know. You could bring in a monitor, and it could just be one little part that's a proprietary part on a board where it's fine on a broken monitor. You just pull it off of it and swap it. Any other questions? Wow, okay, great. Well, I think that we did a great job on time. I appreciate everybody for coming today. Again, if you want to come and see anything else, or if you have any other questions that come to you later, want to see some other cool things, one of my friends here, he brought me a laser disc player, and so I've got that set up at the booth, and some other cool TVs, some other, I've got a modified TV where I've added that ability to use RGB on it on a standard set that normally does not have that. So there's a lot more, there is a future for CRTs, and there's a lot of people dedicated not just to preserving what they are now, but trying to come up with methods for the future, and like how do we maintain these things, because there's actually people who are trying to devise a way to, if you have this part, if you have just this part and it works, then we can make an entire new CRT out of it with all new parts, everything else, except for this and maybe this. And then use a completely new design of boards. And then this guy's design, it's an open source project. It's been working for about a year. It's called the Open Source CRT. But his plan is to be able to, you can push all kinds of resolutions. Where we talked about this could just do 240p and 480i, the lower analog resolutions. Well, with his technology, you can take those normal tubes and push them to where they can do modern resolutions. So think about that. I mean, that would be quite an exciting thing to see. All right, well, thanks again, everybody, for your time today. Have a great show.